Alright guys, let's knock out this test 22 review. First one, to be honest with you, the first problem on your test is probably the worst one. So let's go through it anyway. It's not as bad as I'm making it sound. The zeros are -2 and 3i and -3i, so write them as factors. -2 comes from x plus 2, 3i comes from x minus 3i, -3i comes from x plus 3i. Your best bet here is to multiply your conjugates first, which are these two. And when you multiply conjugates, you do FL. So I'm doing x times x, and -3 times +3, -9i squared. That I squared is going to make that an x squared plus 9, because it's really a -1. And then I'm just going to do FOIL here, except I'm going to undo first. Then I'm going to do inner next, because I want the exponents to decrease. And then the outside, then last. And there it is. There's your answer. That wasn't too bad. Number 2, find a polynomial function of degree 5, which means I got to have 5 x's. -2 is a zero multiplicity 2, 4 is a zero multiplicity 1, and 2 is a zero multiplicity 2. So the first one, -2, comes from x plus 2. It has multiplicity 2. 4 comes from here, has multiplicity of 1. And 2, which comes from here, has a multiplicity of 2. So altogether, it should be 5 x's, and it is. You don't have to multiply those out. You can leave it just like that. Number 3, suppose that a polynomial of degree 5, which means it should have 5 zeros, has zeros 1/2, -square root of 5, and -4, find the other zeros. Okay, that's 3. I need 2 more. Anytime you have radicals, they come in conjugates. So that if negative square root of 5 is a 0, square root of 5 is an answer, is a 0 also. If -4i is a 0, so is +4i. So those are your other two. So you got to do on that one. Number 4, divide using long division. You have to show me long division here. Now, technically, I could do synthetic on this one, and you could too. And if you want to check it using synthetic, that is okay, but you have to show me long division here. I'm going to skip this part where x cubed would go. So leave space there. Okay, now remember first. How many times does x go into 2x cubed? It goes 2x to the fourth goes 2x cubed times. So I'm going to multiply 2x cubed times everything in the front. That gives me 2x to the fourth minus 6x cubed. Draw the line, change the signs. That's gone. Bring down the 6x cubed minus 3x squared. Do first again. How many times does x go into 6x cubed? It goes 6x squared times. Multiply everything in the front. That's going to be 6x cubed minus 18x squared. Draw the line, change the signs. That's gone. That's 15x squared. Bring down the x. How many times does x go into 15x squared? This is a long one. 15x. Multiply that by everything in the front. I get 15x squared minus 45x. Draw the line, change the signs. That's gone. That gives me 46x. Bring down the 1. Almost done finally. How many times does x go into 46x? 46 times. Multiply up everything in the front. That gives me 46x. And 3 times 46. Need to punch that in real quick. I don't know that one off the top of my head. 3 times 46. 138. Plus 130. Should be minus 138. Draw the line. Change the signs. That's going to be 137. So now I'm done. My answer, or our quotient, is 2x cubed plus 6x squared plus 15x plus 46. Get off the top. Your remainder is 137. Because it's positive, I put a plus 137 over the x minus 3. Wow. Yeah, that was fun. Long division, always the greatest. Number 5, synthetic. Much better this time. So because it's x minus 2, don't forget you put the opposite in the box. Put the 2 there. Got a 2, a 0, because there's no x cubed. A 3, a 0, because there's no x to the first power. And a -1. Bring down the 2 to start. Then multiply, add, multiply, add, multiply, add, multiply, add. Circle the last number because it's your remainder. Now, remember, we always start our quotient 1 degree less than we started. We started with 2x to the fourth, so my quotient is going to be 2x cubed plus 4x squared plus 11x plus 22. And because 43 is positive, I put plus 43, x minus 2. Number 6, use synthetic substitution. You got to show your work here to find f of -1 and f of 4. So I'm actually going to put if they give you f of -1, you actually put the -1. Don't change the sign. Put the -1 in the box. I need a 0 where the x squared would be. And here I go. Bring the 1 down. Multiply, add, multiply, add, multiply, add, multiply, add. Whatever your remainder is, that's what f of -1 is. That's what we would have gotten had we plugged -1 in for x. Do the same thing with the 4. Use the same numbers here. All right, bring the 1 down. Multiply, add, multiply, add, multiply, add, multiply, add. Got 80. I'm going to put F of 4. If you couldn't read that over there, that is 80. Number 7, determine if those are zeros. To figure out if there are zeros, do the same thing. I'm going to take the I'm going to take negative 3, put it in the box, and see if I get a 0. 1, 3, 5, negative 6, and 18. Everything's there this time. Start off by bringing the 3 down. Multiply, it's negative 9. Add, multiply, add, multiply. Look what I got. So negative 3 is a 0 for sure. So I'm going to put negative 3. Yes, that is 0. Let's try the 2 also. They both could be. You never know. I mean, this is x cubed, which means it has 3 zeros. Bring down to 3. 2 times 3 is 6. That's 11. Multiply. That's going to be 16. No. So 2 is a no for sure. Some review stuff here. Number 8, solve this one. Radical equation. Start off by moving that 1 to the other side. So I have square root of x plus 3 equals x plus 1. Square both sides, remember? Don't just square each term, but square both sides. The left-hand side is going to be x plus 3. The right-hand side, we're going to square, multiply, double, square. Because there's an x squared, I need to move everything over. If I take that x over there, makes it minus x. 2x minus x is 1x. And then take the 3 over, I get minus 2. So it gives me minus 2. Factor it, I get x plus 2 and x minus 1. So my 2 answers are negative 2 and positive 1 maybe. Remember, we got to plug them in. When I plug in negative 2, no way. I don't think. Nope, does not work. If I plug in the 1, let's see, 4, it'd be 2. Yep, 1 works. That's awesome. So one of them does work. Number 9, this is backwards of what's on the front page, so this one shouldn't be too bad. Right, find the zeros and their multiplicities. Remember, their multiplicity is just their exponent on the factor. So negative 3 is a 0. It has multiplicity 3. 2 is a 0. Multiplicity 1. You don't have to write multiplicity 1 if you don't want to. And negative 4 has a square, so it's multiplicity 2. So I could do on that one. Number 10, use the graphing calculator to find the real zeros. That's where I'm going to punch that in. I'm going to go left bound, right bound, find all the zeros. There could be up to 3 zeros. So I'm going to punch it in real quick and find them. Okay, and there they are. I know that appeared quickly. I had to stop the video so it wouldn't be so long. Punched in my calculator, left bound, right bound, found all 3 zeros. Y'all are great at that. Not too worried about that one. Number 11 has absolute value. 2 bars, 2 answers. 2 bars, 2 answers. Remember, do not take the bars away, though, until you get it isolated. So move that 5 over. That gives you 3. So I'm going to say x minus. That means the absolute value must either be 3 or negative 3. Move the 2's. That's going to be 5. Move that 2. That's going to be negative 1. There you go. There's your 2 answers. Almost there. This is less than. It could be greater than or greater or less than. This is definitely a less than. Because it's less than, you can write it all together. You can go just like this. Then I'm just going to add 7 to all 3 sides. Remember, if it was or, you have to write 2 separate equations, and we'll solve them both. I'm going to get 19 there and negative 5 there. So my solution is going to be between negative 5 and 19 with brackets because of the equal sign. Number 13, fraction equation. Do 2 things first. First of all, let's figure out what x cannot equal. X can't be, we need to factor that denominator. That's x plus 3, x minus 3. X cannot equal either positive or negative 3 when I get done, and to keep that in mind. I'm going to multiply every single term by the LCD, which is x plus 3, x minus 3. I'm going to do that times all 3 terms, even this last one on the right-hand side. Okay, here we go. So on the first one, the x minus 3's cancel. That leaves me a 5 and an x plus 3. On the second term, the x plus 3's cancel, which leaves me a 3 and an x minus 3. On the last one, everything cancels, which just leaves me a negative 2 in my numerator. And then you're ready to solve. Okay, once you get to the second line, you should be good to go there. So just distribute the 5, 5x plus 15. Distribute the 3. And let's go here. 5x minus 3x is 2x. 15 and 9 is 24. That's negative 2. Let's move the 24 over and divide by 2. Bam. Now, is negative 13 okay? Yes, it is, because it's not plus or minus 3. So there you go. Let's see. 2 more. Number 14. Simplify. This is square, multiply, double, square. So I'm going to square the 2. Multiply together, which is negative 10i. Double it. That's negative 20i. And then square. I get 25i squared. squared, remember that makes that 25 become negative 25. So I'm going to combine that with the 4. 4 minus 25 is negative 21, and don't forget your negative 20i. And there you have it. And the last one, number 15, solve using the quadratic formula. Here we go. X equals negative b plus or minus the square root b squared. I did that in my head. Minus 4ac. I would do the b squared in my head every time if I were you. By the way, c is negative 3. All over 2a. So let's work out what's inside that radical. It's going to be 25 plus 24. That's 49, which is cool because it works out great. It's bad because you got to do more work. Okay, so square root of 49 is 7 over 4, and here I'm going to finish. 5 plus 7 is really 12. If I do 12 divided by 4, that's 3. If I do 5 minus 7, that's negative 2 over 4, which is negative 1/2. And there you have it. All right, hope that helps. Hope you're using this to do well tomorrow, and I'll see you then.